register load store instruction. Load store, you can call it as load store. We know what is load store instructions. We are talking about load store instructions only. We have single register load store instructions and multiple register load store instructions. Till the last class, we were discussing about single register load store instruction. Okay. We have only two simple instructions, LDR and STR. LDR is loading the register from the memory. STR means storing the data from register to memory. So memory to register, register to memory. Load and store. Load the register, okay. Store the data onto the memory. So load store instructions, two types, single register instructions and multiple register load store instructions. So single register instructions we have clearly studied, you just recall, and we just mentioned all the stuffs. LDR with bytes, LDR with word, LDR with half word. I clearly gave the instructions. Along with that, we have mentioned clearly, make use of the addressing modes. So single register instructions with addressing mode. Okay. So usually called as single register load store addressing modes. Single register load store addressing modes, which we have, if you remember, we said pre-index with write back, okay, post index. So how to do that? So many instructions along with addressing modes, that is called as along with addressing modes. It means that various ways of specifying the operand. Operand means data. Various ways of specifying the operand is called as addressing mode. So instruction inbuilt attached with the addressing mode, then that instruction becomes more effective. So how to use those addressing modes along with the instructions, we have clearly specified. This particular specific instruction, which is load store instruction, has been included with addressing modes. We have clearly specified in the last class. When we say an instruction has pre-indexing concept, when an instruction has pre-indexing with write back, when an instruction has post-indexing concept. So the examples I have given clearly. What is that? The preconditions before execution, post condition after execution. Now let us discuss about multiple register load store instructions. Okay, so once we complete this, we will be left with the stack instructions and the is that PSR instructions. Okay, okay, that is program status register instructions. So once we complete that, that unit will be complete, so that we can move ahead with the next unit with the thumb instructions, which are a special type of instructions. After that, interrupts we need to go ahead. So this is the last part of the instructions as per concerned with respect to data transfer, right? Multiple register load store instructions. So what is the idea behind this? So you can have, the idea is very simple. You just can say, so you can have load store. What is that? You can have load store multiple instructions. Multiple instructions. Okay, multiple instructions. Load store multiple instructions, I can name them instead of saying multiple register load store instructions. Load store multiple instructions also another name. These instructions, what they do, can transfer, main purpose of this, you see, can transfer multiple registers. Please understand, registers between, what is that? Memory and the processor. Please understand, memory and the processor in a single instruction. Please understand, in a single instruction. In one instruction, I can transfer multiple register contents, okay, to the memory or memory to the registers. So it means multiple register contents. Earlier, single register content, one register content we are passing to the one memory location. The register may have 8-bit, which can be called as byte of data. A register can have half word, it means 16-bit it can have. A register can have 32-bit, 1 word. So each data can be transferred from a register to memory. When we called in single instruction, and in single register load store instruction, there we are moving the content from one register to one memory location or from one memory location to another register. vice versa. But here what he says, multiple register contents can be moved to the memory or from memory to the multiple registers. That's the advantage of this. Okay. So it has one interesting parameter that plays an important role to understand the instruction. What is that? The transfer, what you can say, second, the transfer. What is the transfer? We are doing the transfer, content transfer, right? The transfer occurs from a base address. Please remember, base address register. So instruction must and should have a register called as base address, which I name here as RN. What it does, it is pointing, it is one base address is there, base address register address, which is pointing into memory. So using that, we will be able to assign the values to the memory or get the values from the memory to the registers. Okay. Now how it is useful or how it happens. So the usefulness is, you can say, multiple register instruction, right? Multiple register instruction, multiple register instructions. What they do? Multiple register instructions uh, are are more efficient. You can say are more efficient. Multiple register instructions are more efficient. So when I say this, on what basis? Are more efficient, okay, compared to from what is that? Single register transfers or instructions. You can call it a single register instructions, or you name it as transfers, right? Okay. Compared to the single register transfer, multiple register instruction transfer is much better, he says. Okay. Why? Because because due to, you can say, or for what purpose? For moving blocks of, you see, understand, blocks of data around, okay, around memory and saving saving and storing, you can call it as saving and storing content and stacks. You can say stack is a memory location, you can store, okay, the contents. You can save and store the contents. Okay, that is the one thing. Blocks of data movement is the most important. Okay, which can happen using a single instruction. Which instruction? Multiple register load store instruction. It's a single instruction. That is what one. This thing is there. What is that? Load store instruction. Whatever you call it as load store. I'll write because it should get into your mind. Load store multiple instruction, whatever we have, can, what it does, can increase, you can say, can increase interrupt, please understand, can increase interrupt latency. Try to understand. It means when interrupt occurs, okay, when interrupt occurs, you just say when interrupt request occurs, okay, whatever request, you can say a request for the processor to move from particular address where it is executing, stop there and go to some other address location and try to execute that routine and come back. That is what the interrupt do. How interrupt works, we'll see. When the interrupt request occurs, what will happen? When interrupt request occurs, these these instructions, I mean, load store multiple instructions. Okay, these instructions means load store multiple instructions will offer the latency. Latency means latency for interrupts. So it means higher preference will always be given to the interrupts in the processor. So if our processor doesn't have the preference for the interrupt, then the task which has to be executed will be delayed. So it means that is not the best processor. So the processor, when the processor is called as best processor, means it should execute all the routine programs in a fraction of time. That's what the interrupts are very much powerful and useful. So no one should stop the interrupt. When interrupt occurs, it means the processor has to go to that particular memory location, execute those particular instructions, and come back and again continue the uh, present execution. So like this, it has to happen. If interrupts are delayed, that is called latency. Latency means delay. So the drawback of multiple register instructions in ARM processor is they offer latency or the delay for the interrupts. Okay, so why it is so? Because it is for example, okay, let me take example, ARM 7, okay, ARM 7, okay, ARM 7, a load multiple instruction. In ARM 7, a load multiple instruction, what it has, load multiple instruction takes how much time? T plus NT cycles. Please understand. A load store multiple instruction takes this much time. N is the number of registers. N is the number of registers to load. N is the number of registers to load, and you can treat T is the number of cycles. Number of cycles. Please understand. Together, N is the number of registers to load, how much, and T is the number of cycles. Together, it represents those many cycles are required to execute this particular multiple instruction. When multiple instruction load store multiple instruction is executing by the ARM processor, it doesn't allow any of the interrupts to happen. So, for example, if interrupt is raised, if interrupt has been raised, let's assume, has been raised, then it has to it has then it has no effect. Please understand, no effect until the load store multiple, I'll write it because important, multiple instruction is completed. Please understand. That's the importance of load store multiple instructions. Hence, in many compilers, how the care has been taken for load store, in many compilers, they will take care by providing the switch. So many compilers, many compilers, compilers, many compilers take care of interrupts, on time by by providing, how they do, by providing a switch to control, what to control the minimum number of registers, very important point, minimum number of registers being transferred being transferred. Please understand, the word meaning is, if I wanted to transfer 3 registers data to some memory locations, 4 registers, 5 registers, 10 registers, if I take, in a multiple instruction, if I use those many registers, I wanted to transfer the contents of 10 registers when I give, it takes more time. If I use less number of registers, the contents of those registers has to be transferred to the memory, it takes less time. Then it gives an interrupt latency, less latency for the interrupts. When interrupts happens, interrupt should not wait for long. So that care will be taken care by many compilers. Now how the syntax of load store instruction goes? It says load multiple instruction, load store multiple instruction, M. Okay, load store multiple. So what is that? Store multiple instruction, load multiple instruction, store multiple instruction. You can name separately. Load multiple instruction. Earlier you recall LDR was there, it is now LDM. Okay, so you try to think over the differences and work accordingly. LDM. So this has associated with the condition. This is what the clear representation we have in the textbook. So we can say addressing mode. So it has associated addressing mode. There are some two different addressing modes over here. Okay. So one addressing mode is increment after, another addressing mode is you can say decrement after, something like that. Okay. So what is that? Increment after, increment before, decrement after, decrement before. They can be referred as addressing modes associated with the instruction. I can put them over here. It means an instruction name can become like this: load multiple increment after LDMIA, store multiple instruction, store multiple increment after STMIA, load multiple decrement after LDMDA, you can call it as load, sorry, store multiple DA, decrement after or decrement before. So likewise, you can name by providing the addressing mode accordingly. And as I said, the format of the instruction is associated with the base register. This is the base register RM. I am using here what I listed above in the second line. Transfer occurs from the base address register, which has been associated with RN not symbol. Not symbol is very important. We said in the previous example in the single register instruction, single register load store instruction has the not. It means pre-index with write back. So it means you need to store that address. That is what the concept here is saying. Okay, followed by registers. Please remember, followed by registers. As I mentioned, how many registers you want to use and how many data you want to transfer. That is what the thing all about. Okay. Now you please remember here, what is the idea? We have the table for addressing modes. I'll just write down all those things. If I just have the base register, okay, so I have base register. In the instruction you can see I have base register RN. RN finds, determines the source or destination address for load store multiple instruction. Please, what this RN indicates that you should know. What is that? It determines the source or destination. The source or destination address. Please understand. It carries the address, source and destination address, or it points to the source or destination address. When I say it points to the destination address, it means that load might be using. When I say it is points to the source address, store might be we are using. So that's how RN can be utilized. It is pointing to the source address or destination address in the instruction accordingly. Okay. For, you can call it as for load store or load store multiple instruction. I'll write like this. Multiple instruction. Okay. This register can optimally be updated following the transfer. So it means and register, and this register what it does, this register gets updated. How? Gets updated, okay, with what? Optimally gets updated with the address because of using not. You can say updated with character. So like this you can write. Okay. So this is how the analysis goes on. So this is the major scenario. Now if you represent, it is similar to the single register addressing what we said. Okay. So just understand this. Now, I'll write it over here. Now we'll just check out. So what is this? If I told various addressing modes. Addressing modes are there associated with these instructions. Addressing modes for, you can say, load, store, multiple instructions. I'll call it as, correct? Load, store, multiple instructions. So what are the addressing modes I specified? I clearly said addressing mode. I will write here. Let's say addressing mode, and what is the what description? It is there in your textbook, but still description. Then what is the start address? Just understand this start address. How to understand the instruction? It is associated with the addressing mode attached to the instruction, you can call it. So what is this? You can check this. I have first addressing mode, which is called as IA. It means LDMIA. First instruction is LDMIA. What is this IA? IA is an addressing mode. Addressing mode, what is the name of this addressing mode? You can call it as increment after. Please remember, increment after. Increment after. So what is the start address of this? Always start address is pointed by Rn. What is the end address of this? That is decided by how many registers are there. Please understand. Rn, that's what he says, the formula Rn for star of n minus 4. That is how the LDIMA is associated. So what is the end? That means R or not in the sense that symbol character, if I use along with the R, it means that I need to upload R with this particular value, Rn plus 4 star n. So it depends on what is the value of the n chosen, you can say. So we'll just come to know when we use an example with the particular value in an instruction, and how a simple program can be written even using those things can be realized for block transfer. So let's say before, increment before. So what is the Rn value? You just understand. Rn plus 4. Increment before. It means first case is telling that first you transfer the value from the start address of Rn and then increment. But here increment before where you want to transfer, where the Rn is pointing. If Rn is pointing to 2000, 2000 plus 4, it means I'll pass to the 2004 location. I'll start from there. And I'll end where? You just check now. When I start from Rn plus 4, I'll end with Rn plus 4 star n. Okay. So like this, the table is given in your textbook. You can just really go through to have the analysis on various values. Similarly, I can write decrement after. You just say decrement after. So when you say decrement after, here comes the minus sign. So that comes, the second line comes first here. What is that? 4 star n, okay, plus 4. So that's the idea. And what is the end address? Because you are decrementing the reverse way. Reverse way, that of the I and IB. So this is again after R. If I wrote R with not symbol, it should be updated with this value. Okay, R star n, R minus 4 star n. Okay, similarly, decrement before, you can call it as, correct? Decrement before. So what is the meaning? I am saying that first decrement the address pointed by Rn by so many values. Okay, then I can go up to this particular value. That's the meaning. Okay, so again that will be given as Rn minus 4 star n. So values. This is the table which really indicates us what are the instructions available if somebody asks. Then you can easily write, right? What are the instructions available? Make use of these addressing modes and you write LDMIA is my first instruction. If I write LDM, LDM, IB, LDM, I, LDMDA, LDM, LDMDB, STM, IA, STM, IB. Like this I can list STM, DA, STM, DB. So like this I can list and I can make use of any instruction. Then interesting point is where to use this instruction, how to use this instruction. It depends on the logic what we are trying to. For example, let us see an example. What is the example? Now how to understand the instruction? You just try to see the multiple instruction, how it is. Okay. In this example, let's say If I take an example, how to utilize this, for example, register, I'll say register R naught. I'll use the register R naught. Okay, is the base register. Rn, the name Rn is there, I call it as R naught. R naught is the base register. Okay, base register, mm, base register Rn, you can call it as. Okay, so instead of small, I'll write capital for understanding purpose here. R naught, R naught is the base register Rn. Instead of Rn, I will call it as R naught, and associated with not. It means that update the R naught. That's the meaning. Update the indicating that register is updated after the instruction is executed. That's the meaning. And you can also notice that the lower multiple instruction that register are not individually listed. Okay, instead of the character is used to identify the range of registers. It means if I write an instruction, let's understand how it is written. Pre. Pre means, before execution, preconditions. Just try it. Memory 32, if I say, I'm pointing to the memory location, which is 32 bits in size, right? 0x, one address I'll take. What is that? 80,018, one address. So if you say this, what is the value present in that? 0x, hexadecimal number, some 03 store. 03 store. I'll point to the another memory location, which is nothing but I'll write it as memory 32 only. It's also 32-bit address. So what the value I'll store? 0x80014. Let's say this is the memory address. One is 18, another is 14. So what is the value present? You try to understand the difference is 4. Why the difference is 4? 14 and 18 I have written because you know that each location, if I store 8 bits, 8 4s are 32 bits. In that sense, you can think. So that the difference I can keep, let's say 0x02, another value. So if I write memory another, which is pointing to 0x810, something like this. So 3 different memory locations I have taken, and I stored the values 0x01, 0x02, okay, 0x03, likewise. And I use the registers R0. So let's say R0. What is the R0 value? I'll call 0x. Now you understand. 0x008 0010. So it means I made use of R0 having the value as the address. Address itself is the value of R0. So it means that R0 is pointing to the address 80,010, the above third row. It is pointing to that. That is the meaning. And I'll take 3 more registers, simple registers. Let's say R1. I'll tell R1 is nothing but 0x 8 zeros. Okay, so it means all the contents are 0. Okay, so similarly, I'll take the register R2. I'll put all the contents as zeros. Just check. So I'll take another register R3, R1, R2, R3. 3 registers I have taken. So it means the number of registers defined by the multiple instruction, it depends on what kind of processor you are using. So that depends on the value of 2 into NT formula, where N represents the number of registers associated with the T cycles. So that is what the representation. So how many registers are chosen here? 3 registers. So I'll write the instruction like this. What is that meaning? Let's say I wanted to use LDMIA. Load the multiple instruction register instruction. Load the multiple instruction. Load store multiple instruction with increment after can be written like this: R0 when I write, and not symbol if I use. After executing, instead of load R0, comma, it followed by registers. Registers instead of independently representing R1, R2, R3, I will say R1 dash is the character used to say that I am pointing to R1, R2, R3. That's the meaning. That means that these 3 values are taken by the load store multiple instruction. Load store multiple instruction. This is the instruction. This is the load store multiple instruction. Now, after execution of this instruction, what has to happen? So you just observe R0 is pointing to R0 is pointing to 0x 0 0 8 0 0 1 C. Now you try to understand. R0 is pointing to this. Now let's understand. Let's understand what is this. R1 is pointing to the value. I mean R1 is having the value 0 0 4 zeros and the value is 1. Okay, and if I write R2 after execution, you please think I am loading the contents of the registers with the memory locations. You can say it indirectly like this 0x 00002. Then I will have the register R3. So multiple instruction basically moves the blocks of contents from memory to the registers or register to the memory. That's the ultimate solution to represent. How to show this? When this single instruction LDMI R0 comma R1 minus R3 get executed, that's how it can be visualized. Okay, so it's like this. So if I write here, what is that? If you see the graphical representation of this, it has been shown in the textbook also. You can see this. What is that? So now if I write here, what is that? 0, see, 0, 0, 0. Some value I'll write. It is like 4, correct? Then 0x 8 followed by 1c. Let's try to understand this, what I'm writing. Then I will write the same small change. So let's say the value is 4. Then, okay, then I will say, so if you take this value, okay, let me write like this. So first one is 1c, then I'll write it as 1 8, then I'll say 1 4, then I'll say 1 4, then I'll say 1 0, so then I will say c, that is 0c. 0c. Try to understand the difference. 1c 0c have a gap of 4 4. It means it's a 8-bit memory location, and you can see 80,000 C to 80,010. There is a 4 memory locations. I mean 8000C, 8000D, 8000E, 8000F. Then 10 starts. 10, 10, 11, 12, 13, then 14. From 14 to 18. From 18, 8, 9, A, B, then C, 1C. So 1C to 2C. So likewise, so it means 32-bit word, 4 memory locations they have used. Each one is of 8 bits. You can say 8-bit memory location. Whatever may be the memory location, either 8-bit, 16-bit, or 32-bit, we can easily map and upload the data according to our requirement. Now, interesting point is what we wanted to show here. If I am pointing, if I am having this, so this is my data, okay, and this is my memory address, right? Mem address. So this is my memory addresses, this is my data. Now when we take R0, when we say R0, R0 is pointing to whom? So R0, let's say R0. R0 is the person, he is the register used in our instruction. He is pointing to, he is pointing to the content like this. Content, he is pointing to 0x8 80,010. You can see in the program. he clearly said precondition R0 is equal to 0x00080010. It is pointing to this memory location. Now, with this, what is the meaning? The meaning is it is pointing to 8000 and the value present in that first I should rewrite. Sorry, I did not correct those values. Just a minute. What is that? I would have corrected those values. Please understand these are I could have changed those values like 5, 4, 3, 2, 1, right? So I'll just write those things. Is 5, 4. Okay. 5, 4. Okay, here 3. Write one more here. 2. Then I could have uploaded the data earlier only. Just copy it. Okay. Now you just understand it as like this. So what is the data present in this memory location is 801. So what is the idea here is I have with R0 associated registers are like this. They are written outside. What are those values? You can see starting from R3. Starting from R3. So you just write those things. What is that? Starting from R3. Earlier, what was the value? R3 is having 0x000, then it has all zeros. Okay, so 8 zeros. Then what about R2 was having? R2 was having 0x 8 zeros. Again, similarly, R1 is having nothing, right? 0x 8 zeros. No values are uploaded. So now this is before execution. When I execute the instruction, this is what exactly the instruction is telling about precondition. Now, when I execute the instruction, what will happen? The contents of this are uploaded. Okay, you can say this is the pre-execution. So when I upload this, it means I am moving the contents 1, 2, 3 to the registers and pointing this memory location. What is that? 14, 18, 1C. Now my cursor will point to 1C. So it means I'll, after execution, you just observe. After execution, you can just say R0. Okay, so R0 is pointing now here. R0 will point now to that's the address. Check it now. R0 will point now to 1C after execution. What about the values of this? The values of this are replaced now. So we just understand the values of this. The values of these are replaced. So what is that replaced? Starting from 80,010, 1, 2, 3 are respective 3 locations that will be uploaded to these registers, and the R0 is updated with the address 80,001C. That is what happened here. So the register contents are updated like this. the register contents are updated like this. So what are the register contents? You can call it as 432, correct? The register contents. Please understand the register contents 4, sorry, yeah, what is that? 4321, sorry, 321. 3, 1. Just understand this. 3, 2, 1. Just trying to match this, you just check out this. That's all. So this is what happens. This is associated with LDMIA. Now, before execution, it was pointing to 80,010 and the data associated is 1, 2, 3 in the upper locations, and those three data are passed to R1, R2, R3 automatically, and R0 is updated to the register 80,001C, because in instruction we have used only 3 registers. That's what it is updated the values continuously by incrementing itself and moving the values to the registers R1, R2, R3, and presently it is pointing to the address 80,001C. That will be updated. That is the instruction. After the execution of this thing will happen. This is what you should write before and after, how the graphical representation of the memory location looks like with the data you should show. Similarly, if I check this instruction with the, what is it called as LDMIB. LDMIB. So it means that it is after increment. Please understand. After increment, the data is passed. Correct? After increment, the data is passed. Now, what if for increment before? Increment before. So it means that when you say increment before, I am incrementing R0. It will point to 1, 4, and the first value is 2, move to R1. Second value is 3, move to R2. Third value is 4, move to R3. And the address is remaining same. Please understand. What is the difference between this and this? This is increment before. It means which one you need to increment? Increment, you can say R0. I am just writing for your understanding. Before. Increment R0 before passing values, you can say passing values to registers. Before passing values to registers. Okay. So this is how the instruction works. Similarly, you please cross check what is the values of the contents in the above registers. R3, everything same. R3 will have the value 4 now. R2 will have the value 3. R1 will have the value 1. Sorry, 2. 1 is discarded. 1 is discarded in a sense it is not considered because R0 is incremented before. Then the value is fetched. That's the meaning from the memory location. Loading the contents from the memory location to the register, that is what the meaning of load instruction, and it is using the addressing mode called as increment after or increment before, and with the exclamatory sign if it use, update the register value where it is pointing to after the execution. R0 is now pointing to the same thing, 80,001C after execution. So like this, LDMIB. Now you can cross verify the same concept with what is that called as STMIA. Okay, I hope you understood now. STMIB and STMBA, STMDB. Okay, you can cross over. You can think over this. Before that, LDMIB you said, then LDA and LDMDB. Try to work out on these two. That's it. Everything is similar. So these 6 instructions are very important. Using these 6 instructions, how to transfer the blocks of data, from source block to destination block, blocks of memory I am talking about. That one example we'll discuss. That wraps up this explanation of this multiple instructions with addressing modes. We'll stop here. We'll do in your class.